choose that one or that one. It's up to you. If we choose this one, we need to find y, and we need to find v initial. Does that make sense? And then I could solve the problem. If we want to choose this problem, I need to find v final, I need to find v initial, and then I could solve the problem. Which one would you like me to choose? First one? We have somebody who spoke. Anybody? But since somebody spoke, I'm just gonna go with them. I'm gonna choose this equation. And by choosing this equation, now my problem has changed from finding t to finding y. How can I find y? So let's start a new problem and say, can I find y? Y is given by what? Do I know t? This would give me what? So I found the value of y. So far so good. Let's go back to this equation again. I know y. I know the acceleration. Do I know the initial velocity? No. Do I know the time? No. Can I find the initial velocity? The goal is to find it. Is there a relationship to go from y to v? Silvio.
Is this the Bob thing?
Yep, that's the Bob thing. So in order to find the velocity, if you guys remember, we played the game, which is, we call it Bob or Kevin or whatever. I forgot. So V is gonna be delta Y or delta H, delta. If you take Kevin or Bob or whatever and differentiate it, or do the game we did, it will give you velocity. So, Alex,
So it's 90 squared.
so he took 3 times 3, which gives you 9, and then you're gonna take the 3 and make it less, would be. Now, the package was going up. After 2 seconds, could we find out what was the velocity of the package? Because the package wasn't at 0. It was at 0 if you're standing in the helicopter. If you're standing here, the package was moving up. Do we all agree? So can I find the velocity? So to find, this is v. To find v initial, all I need to do is substitute the time in there, which gives me what? Now, are we done? Is this problem over?
No.
No, all of this work and nothing. What are we looking for?
Time.
Let's go back to our original equation. Do we know the initial velocity? Do you know why? What is the only unknown in this equation?
Time.
So that's exactly what I'm gonna do. So, Silvio, or who else? Dexter, in your universe, what are the signs?
We'll just go classic for everybody's sake.
Win.
Fine, we'll call those negative though.
Too late now. Anyway, it really doesn't matter. So we are gonna delta y equals the initial t plus 1/2 a t squared, and Dexter universe up is positive and right is positive. So let's go and look at y. What was y? 24. Positive, negative? Where did the package start? Right here. Where did the package end? Draw an arrow from where it started to where it ends. That arrow points up or down?
Down.
And according to Dexter, down is?
Negative.
According to Silvio, it's positive. According to Dexter, in the Adalot universe, it's Okay, V initial. What was V initial?
36.
36. Positive or negative? Why is it positive? Because the package initially was going up. Do you guys agree? Yeah? No?
Sure.
If you jump off of a car going 20 miles an hour, do you still go 20 miles an hour?
Yeah.
Yeah, you do. As you will find out. T plus 1/2. What is G? And positive or negative? You accelerate downward and downward is negative. How many of you could solve a quadratic equation?
Put it into the calculator. Quadratic equation.
All of you. How many of you could put that in a calculator? How many can't? If you can't, YouTube it. Put your calculator name, not put it in Google. Google will give you the answer. Or if you guys remember from way back then, if you have an equation that looks like this, which we call a quadratic equation, the solution to this equation is given by minus b plus or minus the square root of 4ac.
Delta square minus 4ac.
Good. Where in this case, what is A? 4.9. What is B? And so in this case, A is 9, B is negative 36, and C is negative 24, and you guys could do the rest. Or, if you hate solving quadratic equations, you could find B initial from here, and then you could find V final, too. So you could use it in that equation. To find V final, we could use that equation. You know V initial, you know Y, you know A, you could find V final, and once you do that, you could use equation number 1, and that would enable you to do it without solving quadratic equation. Either or. You want your homework back?
Mine? No, I got it right.
So that gave 2 prizes. Which one is correct, the small one or the bigger one?
The one that is positive, most likely you're gonna get one negative. We don't have negative time. I don't know. Anybody solved this? No?
Oh, yeah, I did.
So these will have solution. One is positive, one is negative. Since we don't travel back in time, unfortunately, we have to take the positive. Yes?
So the biggest thing that I was struggling with was, I remember when I was reading the textbook, it said sometimes the acceleration at point A would be positive, and sometimes it would be negative, and I couldn't find really in the book that said exactly when. And that was confusing.
It depends how you choose your reference frame. Does that make sense? So like, if Dexter decided not to wimp out and went like this,
Still call that positive though.
this would have been positive, this would have been negative, and this would have been positive. So it depends how you choose your coordinates. Good? It depends where, it doesn't mean anything. All that Dexter says, if you get a negative number means you are pointing up. If you get a positive number, you are pointing down. If you get a negative number, you point to the right. If you get a positive number, you go to the left. Or Professor Adelot would say, If you get a positive number, walk steps to the right or walk steps up. Or if you get a negative number, walk steps to the left or walk steps down. Either or, it makes no difference. It just gives you a way to know. So if I say walk 4 steps right, 4 steps left, that's all it means. But if you're facing me, you'll walk totally different from what I'm thinking. Does that make sense? Because this is my right and this is my left, while on the other hand, you're this way, or this is your right and that's your. It really doesn't matter. We all agree there's a package. That's the physical part of it. Describing it doesn't make any difference. What was the other one?
The subway one, 41.